Okie doke. So now we're going to talk about exponential decay. So if you think about it, decay is the opposite of growth, right? Growth is things growing, right? Decay is things rotting and shrinking, right? So when we talk about exponential, basically it's going to be any number that is less than 1, right? So before we said everything's bigger than 1, well, in these cases, the numbers are less than 1. And all you got to do is think about what happens to fractions when you raise them to exponents. So let's start with a real easy fraction like 1/2. So when you raise 1/2 to exponent of 1, right, you get 1/2. When you raise it to the second power, it's basically 1/2 times 1/2, so you get 1/4. When you raise it to the third power, it's 1 over 2 to the third power, which is 1/8, right? So what happens is as the exponents get bigger and bigger, right, your number, right, your output gets smaller. So as x increases, right, y decreases. So basically, if you could come up with a constant slope, it would be negative slope, but it's exponential, so you're not going to find a constant slope, right? But so these are basically going to be almost like the opposite. They're basically kind of the opposite of growth, right? So with growth, you always had something that sort of looked like this. These are going to look like that instead, right? And you'll see why when we do this. Okay, so let's assume that we're going to start in the exact same situation we were in before. So let's make a table. I've shown that my writing skills with the tablet are super weak, right? So we're going to get some assistance here. Okay, so let's start with how we did with, we're going to go -3, -2, -1, 1, 2, 3. Okay, so this is where we got to really have kind of strong fraction and exponent skills, right? All right, so if we're putting in 1/3 to the x, right? We're raising this whole thing to this power. This means we're taking 1/3 and we're raising it to the -3rd power. Now, when you raise a fraction to the -3rd power, okay, so when you raise like 1/2 to the -2 power, basically it's the same thing as flipping this and then losing your minus sign here, right? So it becomes 2 to the second power, right? So this 1/3 over to the -3rd power is the same thing as saying 3 to the third, which is 27. So that's really, really big, right? Now, if we do 1/3 to the -2 power, flip your fraction, so it's 3 to the second power, right, which is 9. You do the 1/3 to the -1, so flip that thing around, 3 to the 1, so you get 3. And then when you put in, oh, I forgot 0, so we need 0. So if we do 1/3 to the 0 power, well, thank God we got one normal one, right? So that's just 1, right? Now when we do 1, sorry, we're kind of cramped here. 1/3 to the first power is just 1/3, right, which is 0.33 repeating, right? 2, you have 1/3 to the second power, oops, I wrote that wrong, is 1/9, which is basically, you know, that, right? And then when you get 1/3 to the third power, that's 1/27th, which is, you know, really small, right? It's like, I don't know, 0.06 or something. It's tiny. It's very small, right? So when we graph this, right, so we get -1, -2, -3. We're going to go here and do this by, I don't know, we'll do 3s. So we'll do 3, 6, 9, 12, 15, 18, 21, 24, and 27. And so my -3, 27 goes right up there at the edge of the graph. We get 9 down here, so we're really hammering down fast, right? And then -1, you get 3, right? And so now it's like hitting the brakes because we're going to hit the ground soon, right? And then you got 0 is 1, so you're right here. And this is where you're in your turn, so you don't hit the ground. And then everything from that point on is just going to progressively get smaller and smaller and smaller, right? So this is exactly what we're used to from the last one, except that it's just inverted. It's turned the other way, all right? And so my asymptote is still the x-axis, right? And so our domain and range are exactly the same, right? My domain is still all real numbers, right? And my range is y is greater than or equal to 0, right? So really, the shape of the graph did not change from, this would basically, is basically the same thing as if you have y equals 3 to the x, you're going to have pretty much of a reflection over the y-axis of the same thing, right? You're going to have something that sort of looks like this, right? Goes like that. Well, actually, no, not quite. No, yeah, it will look like that, right? So that would be y equals 3 to the x, and this is y equals 1/3 to the x, right? So kind of cool stuff, right? But this really isn't new to you anymore because we're kind of familiar with this, right? And so that's what's kind of nice about this. All right, now we're looking at, all right, how do we transform this thing, all right? Well, if you think about what 1/4 is going to look like, it's going to think about the last one, and this one is going to be even more so, right? So we're going to call this 4, 8, 12, 16, 20. Well, this one would be 4, right? -1, so 4 to the -1/4, right? And so we're just doing the parent function right now. We're just doing this. This is what I'm graphing, okay? And then if you put 2 in, it's going to be 16, right? So that's going to put you up here. And then it's going to basically kind of come down. So this is my, oops, that looks like garbage. It's coming, I don't know why this is looking that way. This is not making me happy at all. All right, I'm trying to do this straight, and it's not letting me. All right, so you're going to have something that looks sort of like this and go like that, right? I kind of messed the curve up a little bit in there, but you get the idea. Now, what we're doing here is now, because instead of this being x - 2 would be a shift to the right, so x + 2 is going to be a shift to the left, right? So everything's going to shift over 2 units to the left. So this thing's going to go 2 this way, right? And this thing's going to go 2 this way, right? Or 1 here. This is going to go shift over 2 this way, right? So we're shifting it over that way. It's 2, so it's making everything twice as big. So this now becomes this becomes this, and then this becomes way up here. So it's a lot steeper, right? And then our -3 means we're taking this whole operation and we're moving it down here. So my asymptote is going to be right here. And that's what's nice, is if you understand these transformations, so now I'm doing my upper ones here. If you understand these transformations, right, these are actually really not that bad to graph. Or I screwed that up. I'd say they're not that bad as I completely mangle it, right? But they're not. They're not absolutely horrible, right? Oh no, I did do that right. Right? I'm doing this one, and now this one, which was 8 above, so you go 1, 2, 3, 4, 5, 6, 7, 8, right? 2, 3, 4, 5, 6, 7. Right? So we're up here. And so I'm going to erase the stuff I don't need anymore, right? So I'm going to get rid of all of this, right? And so this is my parent function right here, right? And then this is my new function that we have created, right? That's going to come down here, again, reinforcing my absolutely awful, weak graphing skills. I wonder if I can do that better. Well, I don't know if it really matters. matters. But I think you guys hopefully get the point of what I'm trying to do. Well, that looks a little better. All right, so kind of like that, right? So this is our new one, right? That's this right here, and you can kind of get that all from that, right? It's growing a lot faster now, right? It got shifted and it got dropped. So a lot going on with it, but like I said, pretty straightforward stuff. So hope this is helpful, and we will see you in the last video here.